Okay, so today we're moving on to 7.7, which is still factoring, but it's going to be factoring special products. So this is just going to give us some special patterns to look for. Everything we do is exactly the same. Okay, so the difference of two perfect squares. So if both my first number and my last number are perfect squares, so here's an example of that, and it's got a subtraction sign in between it. That's key. It can't have an addition sign. It's got a subtraction sign between it. It just factors into the square root of each of those numbers, one being added and one being subtracted. So if I have x squared minus 9, the square root of x squared is x. The square root of 9 is 3. I make one x plus 3 and the other one x minus 3. So if I have a perfect square trinomial, so the first term and the last term are both perfect squares, and the middle term is twice the square root of both those numbers, then it factors into just the square root of the first term plus the square root of the second one being squared. So for example, if I have x squared plus 6x plus 9, well, x squared and 9 are both perfect squares. The square root of each of those would be x and 3. And then if I do x times 3 and then times 2, I do get 6x, and so that shows me it does fall into that pattern. This isn't one of those things that's just like, earth-shattering or anything like that. It's just giving you some patterns that might make your calculations a little bit easier. And the same thing, but if I have a subtraction in here, it turns into the exact same thing, the square root of each of the numbers, but a subtraction sign there. So let's go ahead and try some of them. So if I have s squared minus 49, well, those are both perfect squared numbers. So, and it's subtraction, so that's that first rule we learned. The square root of s squared is s, minus the square root of 49 is 7. We make one s minus 7 and the other one s plus 7. But you don't have to have this rule memorized because you can still identify what A, B, and C are and use our rule that we talked about. So A in this case is 1. B is 0. There isn't just an S term. And C is negative 49. So if I set up my X, A times C goes on top and B goes on bottom. Two numbers that multiply to give me negative 49 and add to give me 0 are 7 and negative 7. When I divide them both by my A term of 1, I get the exact same factorization. So again, you don't have to have it memorized. You can still factor it the same way. But if you do have it memorized, it'll save you a little bit of time. All right, so number 2, again, it's two perfect squares. They're being subtracted, so I take the square root of each one of them, make one addition and one subtraction. And that's it. Again, you can set it up using the factoring methods we've already learned. Number 3, even though it has a 4 in front of the g squared, 4 is still a perfect square. So the square root of 4 is 2, and the square root of g squared is g. The square root of 25 is 5. So I have 2g minus 5, and then I'll have a 2g plus 5. Try number 4. All right, so square root of 36 is 6, square root of h squared is h, square root of 121 is 11, so I'll have 9 and 11, and I'll have 6h plus 11. Okay, so just like with our previous patterns that we learned, you can apply these rules to simplify a problem like number 5. So it's the difference of two perfect squares. The square root of 57 squared is just 57. The square root of 53 squared is 53, so it'd be 57 minus 53, and then 57 plus 53. Makes my math a little bit easier because 57 minus 53 is 4. 57 plus 53 is 110, and 4 times 110 is 440. So again, just using that special rule makes the math a little bit easier than doing 57 times 57 and then doing 53 times 53 longhand and then subtracting those answers. This way is just a little bit faster. But again, just little shortcut rules, nothing that you have to have memorized, but it can make the problems a little bit easier, make that mental math a little bit easier. Okay, so let's get down to number 8. For number 8, we've got x squared plus 16x plus 64. So my first term and my last term are perfect squares. I can take the square root of each of those, which will become x and 8. And then because the middle term is 2 times it, I know that it's going to be a plus sign here, and then it's going to be a plus sign here. This one can be rewritten as x plus 8 squared. Again, you can always do this the other way. If you didn't notice they were both perfect squares, all you have to do is identify that A is 1, B is 16, and C is 64. Set up your factorization. A times C goes on top, B goes on bottom. Two numbers that multiply to give me 64 and add to give me 16 would be 8 and 8. Divide them by my A term. So it still works, gives me the exact same thing. Okay, number 9, again, I've got perfect squares, p squared and 196. The square root of 196 is 14, and 14 times 2 does give me that 28, so I know it's going to follow my rule. So I can just have p plus 14 being squared. Number 10, a squared is a perfect square, 81 is a perfect square. The square root of 81 is 9, and 9 times 2 does give me that 18. However, because it's subtraction, I know it's going to be subtracting here. So a minus my 9. Oh, what's going on with my pen? And then squared. I don't know why my pen is acting funny. Okay. And the last one, both of these are perfect squares. I've got a 10x, and the square root of 1 is 1. It's a subtraction sign, so I'll put subtraction in between them. And I could have written this one as 10x minus 1 squared. All right, so again, why are we doing all of this factoring? Well, it's because we want to be able to ultimately solve equations that have quadratics that have our x squared in them. And to do that, we have to be able to use the zero product property. The zero product property says that you have to have two things being multiplied together equal to 0. So on number 12, I don't have two things being multiplied together equal to 0. But if I factor it, so I can factor this one as x minus 12 and then squared, because it's the difference of two perfect squares. I'm sorry, not x minus 12 squared, excuse me. That would be x minus 12 times x plus 12. So you can see I quickly wrote down the wrong rule. It's very possible that you could as well. Being able to go back and check your work. So think about the distributive property. Make sure it actually checks out. X times x is x squared. X times 12 is 12x, and a negative 12 times x is a negative 12x. So those middle terms would cancel out, and negative 12 times 12 is a negative 144. So thinking about the distributive property to check it and make sure you haven't made a mistake. Then I just set each of them equal to 0 and solve. So I'd have x minus 12 is equal to 0, or x plus 12 is equal to 0. When I solve it, I'd add a 12 on both sides for the first one, and I'd subtract a 12 on both sides for the second one. And I've got my two answers. Remember, if it's not in standard form equal to 0, you get it in standard form, so I would need to subtract the 49 over. So I'd have 9y squared minus 49 equal to 0, and then factor and solve. Okay, so go ahead and take a second and write your summary, factoring your special products. Remember, it's not something you have to have memorized. It's okay to just continue to use the old method that we were using over here every single time. That will work every single time.